Exercise 8.7 Mathematical Technique. The first question is a homogeneous differential equation. It is second order differential equation with variable coefficients, so the coefficients are not constant. This coefficient is denoted by P naught, this coefficient is denoted by P1, and 2 sin x is denoted by P2. We have to check differential equation 1 for exactness. So for exactness, when the differential equation is of order 2, then here we will take 2, and here we will take 1, here we will take 0, here we will take first order derivative, here we will take the second order derivative. Now for exactness, we have to check whether this summation is equal to 0. If it is 0, then this equation will be exact. If this is not equal to 0, then this equation will not be exact. So putting the values from here and simplifying, the value is 0. Therefore equation 1 is exact differential equation whose first integral is. Whenever our differential equation is exact, then we have to take the first integral. The first integral will be our differential equation having order 1 less than that of the given differential equation, and this coefficient, which is denoted by P naught, it will always be taken in the first integral. So this differential equation is the first integral P naught. This is P naught, so we have to take it again here. Since we have second order, so for the first integral we have to take the first order, and if here is P naught, then in the first integral we will start here from q1. So P naught du by dx plus q1y is equal to integral pi dx. Here we will always put pi, and pi is a function which will be here. Since here is 0, so we have to take 0 here. Now this q1, by formula this q1 is equal to p1 minus p naught dash. Whenever we have to find value of q1, then we have to start from p1, and if here is 1, then here will be 0, and here will be first order derivative. So putting the values, where will be the values? These are the values which have to be substituted here, and the value is here minus 2 cos x. So this P naught is this value, so putting the value, this q1 is this value, so putting, and integration of 0 is c1. Now this is the differential equation, and we have to check whether it is again an exact differential equation or not. So for this we have to check the test. If here is first order derivative, then here we have to start from p1, and then here we have to put p naught dash. This is p naught, and this is p naught. This is p1. So putting the value here, p1, this is minus 2 cos x is p1, and this is p naught, and its derivative is cos x. This is the simplification since value. This is the condition for exactness. If here is first order derivative, then we have to start from p1, and here we have to put p naught dash. If the value is 0, then this equation will be exact. If the value is non-zero, then this will be non-exact. Since the value is non-zero, so it is not exact differential equation, but it is linear differential equation of order 1 we have. This differential equation is not exact differential equation, but it is a linear differential equation. Simplifying, that is dividing both sides by sin x. This is the simplification, and this cos over sin can be written as cotangent x, and this 1 over sin can be written as cosecant x. Now since this is a linear differential equation and y is the dependent variable, so minus 2 cotangent x is the value of p. Now we have to find the integrating factor for this differential equation. This is the formula putting value of p. Value of p is minus 2 cotangent x. This cotangent is cos over sine, integration of cos over sine is log of sine x, and this minus 2 is as it is. Now simplifying, we will get e power log of sine x power minus 2. This will be cancelled. Sine x power minus 2, and sine x power minus 2 can be written as 1 over sine x whole square, which is equal to cosecant square x. Here the integrating factor is cosecant square x. Now we have to write the general solution of this differential equation by using this integrating factor. So this is the formula. The general solution is y into integrating factor is equal to integral of q into integrating factor dx plus c2. Here we have used c2 because the constant c1 have already been used. Now putting the integrating factor, this is the integrating factor, this one is the integrating factor, and it is again here. Now in this differential equation we see two functions. This is first function, this is second function. So taking the integral having cosecant and cosecant square, this is the integration. Now we have to use integration by parts. So this is the first function, this is the second function. First integral of second, which is minus cotangent, the rate of cosecant is minus cosecant cotangent, and this value of the integral again here. Now simplifying, this cotangent into cotangent will be cotangent square, and this minus into minus will be plus, and this minus will be again here. This cotangent square is cosecant square minus 1. So multiplying this cosecant square x minus 1 by cosecant x and simplifying, we can write this value can be written again here, and here cosecant into cosecant square, this product will be here along with this negative sign. This minus and this minus will be plus, and cosecant into 1 will be this. Now this integration, this value will be shifted to the other side, to this side, and both of them will be added together, and we will get twice integral cosecant square x dx, and this value will be taken again here, and this integration will be taken again here. Now integral of cosecant is always equal to log of tangent x over 2. Now this is the value dividing both sides by 2, so this will be equal to integral cosecant square, and this 2 will be shifted to the other side. So this is the simplification. Now this is the value. We will put this value here. This is the value of this integral. Hence this equation will become y into cosecant square x is equal to this c1 will be written here, and integral of cosecant x cosecant square x dx will be this value which we see here, and this c2 is here. Now this is the result dividing both sides by this cosecant square, so this cosecant square will be here. Similarly this cosecant square will be here. Now taking 1 over 2 common, so here we see c1 over 2, and this cosecant square will be shifted inside. So this is the simplification, and this 1 over cosecant square is equal to sine square. So this is the general solution of the differential. ये एक दूसरा डिफरेंशियल इक्वेशन है, और यहाँ पे जो कोएफिशिएंट है इसको हम P0 कहते हैं. यहाँ पे जो कोएफिशिएंट है ये P1 है, और ये 2 हमारे पास थर्ड कोएफिशिएंट है. जब कभी हमारे पास डिफरेंशियल इक्वेशन हो, अगर इसका ऑर्डर 2 हो, तो एग्जैक्टनेस चेक करने के लिए हमने कंडीशन 2 से लेना है, और यहाँ पे 1 लिखना है, यहाँ पे 0 लिखना है, यहाँ पे फर्स्ट ऑर्डर डेरिवेटिव लिखना है, यहाँ पे सेकंड ऑर्डर डेरिवेटिव लिखना है. तो जितना ऑर्डर होगा उतना ही हमें यहाँ से स्टार्ट करना होगा. सेकंड ऑर्डर के लिए हमने 2 से स्टार्ट करना है, थर्ड ऑर्डर के लिए हमने 3 से स्टार्ट करना है, और फिर ये डिसेंडिंग ऑर्डर में ये नंबर होंगे, और यहाँ पे डिफरेंशिएशन होगा. सो पुटिंग द वैल्यूज फ्रॉम हेयर, और वैल्यू जब हम पुट करेंगे, सिंप्लीफाई करेंगे तो 0. जब कभी इसी एक्सप्रेशन का वैल्यू 0 आएगा तो इसका मतलब ये होगा कि ये डिफरेंशियल इक्वेशन एग्जैक्ट है. जब कभी डिफरेंशियल इक्वेशन एग्जैक्ट होगा तो फिर हम उसके लिए, उसी डिफरेंशियल इक्वेशन के लिए फर्स्ट इंटीग्रल लेंगे, और वो इंटीग्रल 1 ऑर्डर लोअर होगा और ये पी नॉट हम उसके साथ लेंगे. सो सिंस दिस इज इक्वल टू 0, इक्वेशन 1 इज एग्जैक्ट, द फर्स्ट इंटीग्रल ऑफ 1 इज, तो ये जो पी नॉट है इसको हम एज इट इज़ लेंगे. यहाँ जितना ऑर्डर होगा उससे 1 ऑर्डर हम कम लेंगे. सो पी नॉट डी वाई बाई डी एक्स प्लस के 1 वाई, और यहाँ जो फंक्शन है उसका हम इंटीग्रेशन लेंगे और साथ में एक कांस्टेंट लेंगे. अब यहाँ पे पी नॉट क्या है, दिस पी नॉट इज दिस 1 and this Q1 is by formula P1 minus P naught dash. So where is P1? P1, this is P1. So putting the value of 4x, where is P naught? This is P naught. Similarly, this P naught is again here. So differentiating, so we get 2x. This is 2x. Simplifying, this is the value of 2x. Putting all these values here. So this P naught is x square plus 1. dy by dx, this q1 is 2x which is here, and here integration of cosine is sin x, along with this 2, integration of 2x is 2x square over 2 plus c1. Now from this equation, this coefficient is denoted by p naught. Similarly, this coefficient is denoted by p1. Now we have to check whether it is exact or not. Since here the differential equation is of first order, so the condition for exactness will start from 1, P1. If here is first order, then the condition of exactness will be P1. So P1 minus P naught dash, putting the value from here. So this is the value and it is 0. Whenever the value is 0, it means this differential equation is exact. Equation 3 is also exact. जब भी डिफरेंशियल इक्वेशन एग्जैक्ट होगा तो फिर उसके लिए हमने फर्स्ट ऑर्डर इंटीग्रल लिखना है और वो इंटीग्रल 1 ऑर्डर लोअर होगा, क्योंकि यहाँ पे ऑलरेडी फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन है. तो इसी डिफरेंशियल इक्वेशन के लिए फर्स्ट ऑर्डर हमने लिखना है. इसी पी नॉट को हम लेंगे और इसी फर्स्ट ऑर्डर की वजह से हमने ज़ीरो ऑर्डर डेरिवेटिव लेना है. ज़ीरो ऑर्डर डेरिवेटिव का मतलब है कि हमने इसी पी नॉट के साथ इसी y को लिखना है. तो नेक्स्ट स्लाइड में इसी डिफरेंशियल इक्वेशन का एग्जैक्ट डिफरेंशियल इक्वेशन लिखेंगे जिसमें पी नॉट होगा और ज़ीरो ऑर्डर डेरिवेटिव यानी y होगा और उसके साथ दीगर टर्म्स होंगे. सो लेट्स सी. देयरफॉर द फर्स्ट इंटीग्रल ऑफ 3s, तो हमने पी नॉट लिखा और ज़ीरो ऑर्डर डेरिवेटिव जिसका मतलब है y, और राइट साइड में जो फंक्शन फाई था उसी को हमने लिखा है और साथ में एक इंटीग्रेशन लिखा है. ये फंक्शन कहाँ पे है? ये फंक्शन हमारे पास जब भी एक डिफरेंशियल इक्वेशन एग्जैक्ट होगा तो यहाँ पे जो फंक्शन होता है इसको हम पाई कहते हैं. तो फर्स्ट इंटीग्रल में इसका इंटीग्रेशन हम लेते हैं. तो ये पाई है और इसको हमने इंटीग्रेट करना है. इसी इक्वेशन का जो फर्स्ट इंटीग्रल है उसके साथ इसी फंक्शन पाई का इंटीग्रल लिखना है. तो ये आ गया. अब पी नॉट की वैल्यू हमने पुट किया, ये वाई अपनी जगह पे आ गया. यहाँ पे इंटीग्रेशन ऑफ साइन कोसाइन है, माइनस कोसाइन है, एक्स स्क्वायर का इंटीग्रेशन एक्स ओवर 3 है, c1 का c1x है, ये c2 अपनी जगह पे. तो ये क्या है? हेयर वी डू नॉट हैव एनी डेरिवेटिव, hence it is the solution. This one is the required general solution of equation 1.